You probably use a computer every day, but have you ever wondered what the building blocks of your device are? Let us give you a quick overview of how computer architecture has evolved over the years and what it will look like in the near future. In the old days of computers, we thought of the CPU as the brain of the computer. The reason for that is very simple. CPUs perform the logical operations. In this era, many people measured a computer's speed by the clock rate, usually in megahertz or gigahertz. However, as computer architecture evolved, this metric became less relevant as performance can be affected by a very wide range of design choices. The number of cores in the CPU, bus speeds, available memory, and so on. At this time, GPUs were mostly good for displaying the image on the screen, but not much more. Because of its high power consumption and high performance, this architecture was mostly used in tower desktops. About 10 or 15 years ago, three significant things happened. First, as the popularity of games grew, GPUs became much more powerful in order to be able to render 3D images, in other words, to play 3D games. Secondly, IGP was introduced as the result of integrating a graphics processor with the Northbridge chip. IGPs contained part of the system memory dedicated to graphics. IGPs could work together with graphics cards, now called discrete graphics cards or DGPUs, for additional performance. And thirdly, 64-bit architecture was introduced to CPUs to allow wider physical and virtual memory and programs to store larger amounts of data in memory. The memory controller was also moved from Northbridge to the CPU to speed up the CPU access time to memory. This architecture marks the era of laptops and high-performance desktops. CPUs are great when it comes to processing serial workloads, but GPUs that have many more cores are better at processing parallel workloads. APUs combine CPU and GPU into a single piece of silicon. APUs replaced IGPs. The APU is the future of modern processor design. In many computational tasks, offloading CPU workloads to GPU means greater performance improvement and extended battery life. This architecture enabled tablets, smartphones, and ultra-thin notebooks. The only thing more exciting than doing something better than you've ever done before is doing something entirely new. For example, what if you could log into your computer just by looking at the screen? What if it could respond to just a gesture or your voice command? Many of these capabilities exist today in labs all over the world. Why haven't they found their way to the mainstream yet? The answer is in the limitations of existing hardware architecture and software programming models. And this is why heterogeneous systems architecture, or HSA, is vital to enabling the next era of computing innovation. HSA will remove GPU bottlenecks when accessing system memory and unlock GPU computing performance. This architecture should enable the era of natural user interfaces and surround computing. System-on-a-Chip integrates APU with Southbridge onto one piece of silicon, increasing chip integration and enabling supercomputing in the palm of your hand. This architecture will enable new levels of experience in a thin and light form factor across all of today's devices and facilitate the creation of future ones. There's no such thing as the final state of computer architecture, but SoC and heterogeneous computing represent a quantum leap in processor design and are set to revolutionize how the next generation of computing devices and user experience will look.